In solving this problem, the first thing you need to do is convert the given information into coordinating units. You'll notice the density is given in grams per cubic centimeter. You're given an area in feet squared and a mass in ounces. And so we've got to make those units agree with each other. So the first thing I'll do is convert 50 square feet into square centimeters. I want to do that because the density that was given has cubic centimeters in it, and square centimeters is going to get me closer to where I want to go. So I use the conversion factor that I looked up between the relationship between square meters and square feet, and then I'm converting from square meters to square centimeters using the second conversion factor. I get 46,450 square centimeters. I'm not too concerned at this point with significant figures. I could have put a lot more digits in there based on my calculator, but I just rounded to the nearest number of square centimeters. Ultimately, in this problem, the number of significant figures in my answer should be 2, and so I'm well within an acceptable range right now, so that when I get to the very last step, I can apply the rules for significant figures. So now we're going to convert ounces into grams, again, because the mass portion of the density that was given is in grams, and so I've got to make those units agree with each other. So I don't know, again, I didn't know the relationship between grams and ounces, so I looked it up, 28.35 grams per 1 ounce, used that as the conversion factor, and I got 212.6 grams. So now that we've got units that agree with each other, we've got to think about how to solve this problem. We know what volume is. We know it's length times width times height typically, but we're going to change h to t for the thickness of the aluminum. And then we're going to substitute in area for length times width. So volume then is area times thickness. So we know we were given density. We know density is mass over volume. Well, we can replace volume then with area over thickness. We were given area in the problem, 50 square feet of foil, and we were given a mass, 7.5 ounces, which we converted earlier, and we're now going to plug those units in and solve, or plug those values in and solve for t. Now we're ready to solve. We're going to take the given density, 2.70 grams per cubic centimeter. We're going to plug in the values that we have converted previously, and then we're going to end up solving it for t. We'll deal with significant figures at the very, very end of the calculation. I'm just showing you the setup right now. And so once we arrange this and solve it for t, hopefully your algebra skills are up to snuff here, and that this is not a problem. If it is, brush up on those algebra skills before class starts. If you're unable to, let me know so I can work with you. So when you solve, you get 1.69 or 1.7 times 10 to the minus 3 centimeters. It's got to be centimeters at this point because that's the units that were in the problem before. We can't just tack millimeters on the end because that's what the question asked for. We can't just make it up. We've got to go with what was given, and then we've got to convert in the end here to millimeters, knowing that there are 10 millimeters in 1 centimeter. And so at the end here, I'm rounding to the correct number of significant figures, 1.7 times 10 to the minus 2, because in the given information, 50 square feet has 2 significant figures, 7.5 ounces has 2 significant figures. The density, 2.70, had 3 significant figures. And so your answer, when you're multiplying and dividing, can't have more significant figures than the measurement with the fewest. And so 50 or 7.5 ounces each had 2, so that requires that our answer only have 2 significant figures.